warm welcome to the ACE Online. Coming to myself, Hajarathvali Sir. I'm going to guide you through this theory of machines. And coming to myself, these are my credentials. I secured 14th rank. I secured 45th rank in ESC. I done my masters at IIT Bombay, and I worked at GE Global Recent for 9 years, guys. And I'm having more than 14 years of teaching experience. I have been teaching this theory of machine subject since 2011, guys. Getting a nuts? I'm having a 13 to 14 years of experience of teaching this subject itself. So I know what is important from exam point of view, what is not important exam point of view. So what you have to cover for getting the more score, guys. Everything I will guide you guys. Okay, so please follow me properly. I hope some of the students are my offline classroom students. I hope. Okay, so whatever the same thing I discussed in the offline classroom also, guys, this will be repetitive for you, getting an answer, but in a concise manner. I'm going to tell you what are the important areas you have to focus more in the theory of machine subject. I will give you quick shortcuts to answer the questions in a easiest manner. All these things I'm going to cover, guys. Okay, so without further delay, let us start, guys. Typical contents, there are typical contents: planar mechanisms, gate trains, mechanical vibrations, balancing, gyroscope, cams, governors, and flywheels. And typical weightage, guys, 8 to 10 marks. 8 to 10 marks we can get from theory of machines and vibrations together. But where you have to focus more is, guys, most important, most important. 6 marks will be coming from only these 3 topics: planar mechanisms, gate trains, and mechanical vibrations, guys. And remaining, not that much important. Not much important. But there is scope of getting one question out of all these 5 topics, guys. One question will be definitely coming, either balancing, gyroscope, cams, governors, and flywheels. Out of these 5, one question will be definitely coming, guys. So my suggestion is, if you don't have a time, the focus on these 3 topics. Out of these 3 topics, guys, I'm telling you, focus on gate trains first, because to cover gate trains we just require 2 to 3 hours of preparation. Even if you start from the scratch, just require 2 to 3 hours of preparation. That is enough. One question will be definitely coming from gate trains, guys. That too 2 marks question. That too 2 marks question. 4 marks generally used to get, guys. 3 to 4 marks, guys. 3 to 4 marks used to get from this one. That too very easy, not too much difficult, guys. Coming to planar mechanics, sometimes questions are a little tough, sometimes questions are a little easy, guys. I'm going to cover you where they are focusing more. Those areas I'm going to tell you, guys. So don't worry about it. Okay, yes, mechanisms, guys, where you have to focus more, guys. What I have done is I have written the summary of each and every topic. Each and every topic you have to focus, guys. So I just go through the summary, then we will solve some of the questions based on the summary itself, guys. Okay, yes, let's start, guys. What is meant by theory of machines? It gives what exactly? Relative motion between various links. Next, what is a machine? It converts available energy to do some useful work. So machines having a multiple mechanisms. What is meant by mechanism, guys? It only transfer relative motion between input to output, which means that, guys, from input to output, to transfer the relative motion we need a mechanism, guys. But what is a machine? Machine means, so we are having some available form of energy, we convert into different form of energy, guys. If we take our IC engine itself, having a chemical energy to mechanical energy, in between multiple mechanisms it is having. So a machine contain multiple mechanisms, guys. Next, link. What is meant by link? Link is a resistant body. Resistance means it should resist the deformation, guys. And next one is, it allows relative motion. The link should allow the relative motion, guys. So which means that what does it mean is, I will tell you, guys. Listen carefully. Suppose this is the one link is there, another link is there, both are connected by a hinge joint. Second case, this is the link, both are connected by a welded. Now what I have to do, guys, I have to count these two as a single link itself. Why? Because there is no relative motion between these two, but here there is a relative motion, guys. So I have to count as a two links. Link 1 is the link 2 I have to count, guys. Then kinematic pairs, generally, guys, we are having a lower pair and higher pair, guys. Tell me what is mean by lower pair, having what type of contact? Sometimes direct theory questions used to get, guys. Lower pair means you are going to get a surface contact, guys. Higher pair means point or line contact. In case of lower pairs, we generally use, guys, either revolute pair or prismatic pair. For revolute pair and prismatic pair, what is the degree of freedom, guys? Only 1 degree of freedom exists, guys, and 2 degree of freedom is lost, which means that I'm having one link, I'm having another link. These two are connected by a revolute pair. It allows only one motion, remaining two are completely lost, guys. Next, a typical degree of freedom. This is important, this is a very, very important, guys. Suppose if I'm having a multiple links, guys, and I'm having a multiple joints, they used to ask the question is like, find out the degree of freedom of a system. So what the formula, guys? F equal to 3n minus 1 minus 2p1 minus p2. Here p1 means what exactly? Number of pairs having a single degree of freedom. p2 means number of pairs having 2 degree of freedom, guys. So the formula is something like this: 3n minus 1 minus 2j. p1 single degree of freedom, joint, I'm assuming as a joint, guys, 2j. p2 means I'm assuming as a h, guys, higher pair, guys. Okay, now second thing, this point put a star mark. If the motion of a link doesn't affect other links, if the motion of a link doesn't affect other links, then it gives a redundant degree of freedom. Please repeat, guys. If the motion of a link doesn't affect other links, it gives redundant degree of freedom, then this is the typical free body diagram, guys. So typical equation: F equal to 3n minus 1 minus 2j minus h minus fr. Minus fr signifies redundant degree of freedom. If I solve one question, you get the clarity, sir. Let us check it. Please, this is the question, Amma. Please try to find out the degree of freedom. Try to find out the degree of freedom equal to how much, guys, for this. I am giving 1 minute of time. Please try to find out degree of freedom for this. Identify the number of links. Identify the number of joints. Please try to find out. If this is finished, please try to find out the degree of freedom for this one also. Please, guys. Number of joints, how many first? Number of joints. Listen carefully. First number of links, 1, 2, 3, 4. Slider as a trade as a one link, guys. 5, 6, 7, 8. All fixed links are count as a one link itself, guys. Now tell me, sir, number of links equal to how many? Number of links equal to 8. Number of joints, tell me, guys, number of joints equal to. So if I can say number of joints, guys, this is the joint 1, this is the joint 2. Now tell me how many joints are there, guys. See, at this location, how many links are connected, Amma? At this location, guys, how many links are connected? Link 1, link 3, link 4, link 5. So at that location, there are 4 links are connected, guys. 4 links are connected. If there are 4 links are connected, I have to count as how many number of joints, guys. Listen, if there are n links connected the joint, if there are n links connected at the joints, we have to count as a n minus 1 joints. This we discussed in the regular class also. Why we have to count also clearly discussed. So this is not the right time to say why we are considering, guys. Just remember, if there are n links are connected to the joint, guys, we have to count as a n minus 1 joints. So J1, J2, 4 links. So it should be how much, guys? 3 links I have to connect now. 3 links, guys. I have to count as a J3, J4, J5. J6, J7, J8, J9, J10, guys. So there are total 10 joints. So joints equal to how many, guys, now? Joints equal to 10. N equal to 8, joint equal to 10, guys. Then what is the degree of freedom formula? No redundant degree of freedoms are there. F equal to 3 into n minus 1 minus 2j minus h. Any higher pairs are there in the mechanism, guys? Any higher pairs are there? No higher pairs are there, guys. So h equal to how much? 0. Then how much I'm going to get? 3 into n minus 1. So n is how much, guys? 8. So it becomes 7, guys, minus 2 into 10, guys. How much is coming? 21 minus 20. The answer equal to 1. I hope this is clear for you guys. Now please try this one. Once it is over, please try this one. Please try, guys. I'm giving 1 minute of time. Please try, guys. Please try. First, count number of links. Count number of joints. Count if any higher pairs are there in the mechanism. Count the number of higher pairs, guys. Please try. First, number of links. 1, 2, 3, 4. So n equal to 4, guys. Suppose in the question, if they given 4 and 3 is something like this, now they given a rolling, they can be a revolute pair, guys. Suppose if they are both are not connected, if both are not connected, they given a simply welded point like this, then I should count this one and this one as a one joint only, guys. Okay, yes, as a one joint itself, guys. Now listen carefully. So number of links equal to 4 itself, guys. Number of links equal to 4. Number of joints, tell me, guys. Number of joints equal to joints, revolute pairs. Joint 1, joint 1, joint 2, joint 3, guys. Number of joints equal to 3, guys. Number of higher pairs, how many, Amma? Between link 3 and link 2 having a number of higher pairs equal to 1. Number of higher pairs equal to 1, guys. Higher pairs equal to 1. Then f equal to how much, guys? F equal to 3 into n minus 1 minus 2j minus this one, guys. Getting an answer? How much is coming? 9 minus 6 minus 1. The answer equal to 2 degree of freedom. If you get the answer 2 degree of freedom, this is absolutely wrong. But the question is again, tell me, guys, why? Why this is wrong, guys? Because if you see the previous statement we discussed, guys, if motion of a link doesn't affect other links, if the motion of a one link doesn't affect other links, it gives the redundant degree of freedom. It gives a redundant degree of freedom, which means what does it mean, guys? See, observe carefully. Here, if I rotate link 2, it will disturb other links or not, sir? Definitely it is going to disturb, guys. If I rotate link 2, it will disturb definitely the remaining parts. But observe carefully. If I rotate link 3, if I only rotate the link 3, will it disturb any other links, Amma? No. Are you getting an answer, everyone? See, observe carefully. If I rotate the link 2, guys, if I rotate, because it is having a eccentricity is there from the center to here, some eccentricity is there, Amma. That's why when I try to rotate, it will disturb the other links, guys. But here what is going to happen, Amma? If I rotate 3, it doesn't disturb the other links. As it doesn't disturb the other links, redundant degree of freedom equal how much? 1, because the link 3 having a 1 redundant degree of freedom. That's why I'm writing, right, guys? 1 minus of FR. FR means redundant degree of freedom. How many redundant degree of freedom is there, guys? Only 1, guys, here. So I can write 2 minus 1. The answer equal to 1, guys. I hope this is clear, guys. Okay. Now, understood or not, sir? Yes. Now, if you observe carefully, next one, till this we have done, guys, 6th point. Next 7th point, guys, linkage. What is meant by linkage, guys? The linkage means it is having only lower pairs. Linkage means it is having only lower pairs. So if you observe carefully, sir, so lower pairs means higher pairs equal to 0. When higher pair equal to 0, f equal to 3n minus 1 minus 2j I am going to get, guys. Next, one more thing. If any one higher pair is there, this question given 2 to 3 times, guys, as a theory question. One higher pair can be replaced with what? Because suppose there is a mechanism, there is a higher pair is there. but I want to make a mechanism with only lower pairs, guys, with only lower pairs. What we can do, guys, we can replace a higher pair with, tell me, guys, two lower pairs plus one binary link. Assume this is the link 1, this is the link 2, both are having a higher pair. This higher pair can be replaced with a single link with two revolute joints, guys. And second thing is, if I am having a spring, suppose in the mechanism, given the question is like this, guys. 1 second. If they given the question like this, spring is given, find out the degree of freedom equal to how much if they ask. Find degree of freedom equal to how much, guys? As we discussed here, listen carefully, spring can be converted into two binary pairs. Okay, directly we can't count as a single link. I have to count as a two binary links, guys. Binary links. So what I can able to do, this mechanism is exactly equal to, this is the one is there, this is the one. So I can convert it two binary links, guys. Two binary links, one link here, another link here, guys. Degree of freedom equal to how much, guys? And number of links equal to 4. Yes or no? 1, 2, 3, 4. Number of joints, how many, guys? 4 joints. 1, 2, 3, 4. Number of joints also equal to 4, guys. Number of links equal to 4. Number of joints equal to 4, guys. Then how much I am going to get? F equal to 3 into n minus 1 minus 2 into 4, guys. So 3 into 3 minus 8, answer equal to how much, guys? 1 degree of freedom. So whenever spring is there, guys, whenever spring is there, we can replace the spring with a two binary links. So far most important one is finding degree of freedom. It won't give for 2 marks question, guys, only given for 1 mark question. Generally degree of freedom questions are. Okay, now coming to this one, guys. Yeah, transmission angles are not that much required. If you want, you can omit this one, guys. Transmission angle topic is not required, guys. Okay, and 4-bar mechanism. Inversions of 4-bar mechanism, very, very, very important. High chances of getting the question from inversions of 4-bar mechanism, guys. That too only 1 mark question. Don't expect 2 marks question from the inversions of a 4-bar mechanism. See here, in case of 4-bar mechanism, guys, the inversion, first of all, what is mean by inversion, guys? You know these basics. Don't expect me to cover those basics in this revision class, guys. What is inversion basic? I am going to tell you. Inversion is if the mechanism is having a 5 links, by fixing each link we get the different mechanisms, guys. That is called inversions. The different mechanisms we get by fixing each link is called inversions, guys. Now if you observe carefully, if there are 4 links are there, we get the 4 inversions. 5 links are there, we get the 5 inversions, guys, because by fixing first link we get different mechanism, fixing second link we get different mechanism, fixing third link we get the different mechanism. And here one more terminology is, guys, in case of 4-bar mechanism, listen carefully, sir. In case of 4-bar mechanism, if input make complete revolution, then this is called crank. If input make partial revolution, it is called rocker. Or if output also make complete revolution, it is called crank. Okay, if the output make partial revolution, becoming a rocker, guys. Getting answers, everyone? So you got the idea, guys. Crank means if it is making a complete revolution, input is making complete revolution, it is called a crank. If input is making partial revolution, it is called a rocker. If output is making complete revolution, it is called a crank. If it is making a partial revolution, it is called a rocker, guys. Now if you observe carefully, in case of 4-bar mechanism, guys, first inversion, here it depends upon L plus S less than A plus B. What is mean by L plus S less than A plus B means, guys, the length of the largest link and length of the shortest link, guys. If you take, listen carefully, sir. In the question they mentioned, guys, so assume this is the 5, this is the 2, this is the 7, this is the 6, guys. So length of the largest link is what exactly? 7. This is called L. This is the way you have to specify, guys. So length of the shortest link is what exactly? 2. Getting answer, everyone? If L plus S, if you observe carefully, sir, If L plus S, remaining lengths are A, this is the B, guys. Are getting an answer, everyone? So here L plus S and A plus B. What is L plus S here, guys, everyone? 9. A plus B, how much, guys? 11. So if L plus S less than A plus B, then it is called class 1 mechanism, guys, or Grashof law or Grashof mechanism. Here the type of mechanism depends upon the which link is fixed. Suppose, listen carefully, if it is a class 1 mechanism, if shortest link is fixed, it is going to give you crank mechanism. Crank means input is making complete revolution, output also making complete revolution, guys. Next, if the link is adjacent to shortest link is fixed, it is going to give you crank rocker mechanism. Link opposite to shortest link is fixed, it is going to give you rocker mechanism, guys. Are getting an answer, everyone? Now listen carefully, sir. Tell me type of mechanism it is, guys. This is the one which is fixed here. It is going to give you what kind of mechanism? Yes, crank rocker mechanism, guys. Why? Because link adjacent to shortest link is fixed. It is going to give you crank rocker mechanism. The right answer is CR mechanism. CR mechanism. CR means not class representative, it is a crank rocker mechanism, guys. Next, second case is if L plus S greater than A plus B, so they give the link lengths based on the configuration, based on the length of the links, guys. You have to specify. If L plus S greater than A plus B, by fixing any link, it is going to give you rocker mechanism, guys. Next, third one. Suppose if L plus S equal to A plus B, if L plus S equal to A plus B, and if link lengths are not equal, if L plus S equal to A plus B, if link lengths are not equal, guys, are getting here, sir? So what does it mean? If L plus S equal to A plus B, but link lengths are not equal, so I can write, listen carefully, sir. Assume this is the 3, this is the 7, guys, this is the 4, this is the 6. So what is the largest link? This is the largest link. This is what exactly, sir? Smallest link, guys. Now remaining color A comma B. Now L plus S, this is the A plus B is there. So L plus S is how much here? 10. Remaining A plus B, how much, guys? 10. So L plus S equal to A plus B, I got it, guys. Then it follows what kind of mechanism? That two link lengths are different. Each link having different thing itself. Then it follows same as a class 1 mechanism. It follows same as class 1 mechanism. In the class 1 mechanism, what happens, guys? Shortest link is fixed, crank rocker. Adjacent to shortest link is fixed, crank rocker. Opposite shortest link is fixed, rocker, guys. Same thing applicable here also, guys. Here, tell me, sir, which one is fixed, amma? Link adjacent to shortest link is fixed. Because this is shortest link, amma, I'm going to get a crank rocker mechanism. Next, if all the links are same, like link length is 3, 3, 3, 3, all the links are same, guys, then by fixing any link, it is going to give you crank mechanism itself, guys. By fixing any link, it is going to give you crank mechanism. Next, equal links. I hope this is clear for you. If equal links are opposite to each other, then what is going to happen, guys? If any link is fixed like this, equal links are opposite to each other, like parallelogram linkage is there. By fixing any link, it is going to give you crank mechanism itself. Next, equal links are adjacent to each other, guys. Like S and B are adjacent, L and D are adjacent, guys. Then by fixing shortest link, I am going to get a crank. By fixing largest link, I am going to get a crank rocker mechanism, guys. Should be very careful. But based on my experience, I have observed is, guys, mostly questions will be coming from these two, guys, class 1 or class 2 itself, guys. Okay, so please go through it first. Next, see, next one, guys, inversions of a slider crank mechanism. What is another name for a slider crank mechanism, guys? Because slider crank mechanism having a 3 revolute pairs, 1 prismatic pair, guys. 1, 2, 3 revolute pairs, 1 prismatic pair. So it is definitely, I can able to say 3R 1P mechanism, guys. Here first inversion, by fixing the first link, it is going to give you crank rocker mechanism, amma. So first one is a crank, second is a reciprocating mechanism, I can able to say. So reciprocating engine or pump or compressor all comes under in first inversion itself, guys. Reciprocating engine or pump or compressor, guys. Guys, in the exam they used to ask inversions of like first inversion of slider crank mechanism, option A. like a crank and slotted lever mechanism. Option B, reciprocating engine. Option C, like that they used to ask, guys. Here, reciprocating engine, pump and compressor comes on first inversion, guys. Second inversion, guys, link 2 is fixed. It is going to give you, guys, Whitworth or Whitworth quick return mechanism. QRM means quick return mechanism, guys. And second then, guys, rotary engine. Rotary engine also is a part of what exactly, sir? Inversions of slider crank mechanism itself. Next, third inversion. By fixing the link 3, guys, it is going to give you oscillating cylinder engine or crank and slotted lever mechanism, guys. Crank and slotted lever mechanism. So crank and slotted lever mechanism, Whitworth, rotary engine and reciprocating engine, all are inversions of what exactly? Slider crank mechanism itself, guys. Next, by fixing fourth link, guys, we're going to get a hand pump mechanism, guys. You might have seen the hand pump mechanism. It is also part of inversions of slider crank mechanism itself, guys. Next, 2R2P mechanism. What is mean by 2R2P mechanism, guys? 2R means 2 revolute pairs. 2P means 2 prismatic pairs, guys. So 2R2P mechanism means, guys, listen carefully, I'm having a 2 revolute pairs and 2 prismatic pairs, guys. Then having a first inversion. If I fix the first link, guys, it is going to give you elliptical trammel. The name of the mechanism is, these things are not required, guys. These things are not required. Elliptical trammel is the inversions of double slider crank mechanism. You have to remember this one, guys. What is the purpose of elliptical trammel, guys? Its purpose is to trace the elliptical curves. Its purpose is to trace the elliptical curves, guys. Next, second inversion. In case of second inversion, guys, here either link 2 or link 4, because both are sliders only. If I fix either link 2 or link 4, you get the like second inversion, guys. That is the Scotch yoke mechanism. Its purpose is to produce harmonic output motion, guys. Scotch yoke mechanism comes under second inversion itself, guys. Next, third inversion. Yes, these formulas also not required. Okay, these are also not required. Just remember the names, that is sufficient, guys. Next, third inversion. Why I'm writing is, this is important from ESC point of view, gate point of view, not required. This is the revision class for the gate. That's why not required from the gate exam point of view. Okay, just follow my class. Next, third inversion, guys. What a third inversion? Link 3 is fixed. Link 3 is fixed. The coupling rod is fixed, guys. Then it is going to give you Oldham's coupling. What is the purpose of Oldham's coupling, guys? It connects 2 parallel shafts with little offset, guys. 2 shafts are there, guys. 2 shafts are there. The one shaft, the another shaft. If both are having too much offset, na sir, we can't able to connect with the help of Oldham's coupling. Having a little offset is there, then we have to connect with a Oldham's coupling, guys. The too much offset is there, what to do? How do you connect, guys? Think of it. Suppose that offset is 2, the one shaft is there, another shaft is there. The offset is too much, guys. Then how do you connect, guys? Generally, we connect with the help of either belt drives or either help of gate drives, guys. If the offset is small, then only we go with a Oldham's coupling. I hope this is clear for you. This is the place. You have to remember one question, guys, here. Whenever Oldham's coupling is there, high possibility of getting the question of sliding velocity of a coupler. What is sliding velocity of the coupler, guys? V equal to E into omega. You have to remember this formula. V equal to E into omega. V equal to E into omega, guys. You have to remember this one. Let's see this question. Please read this question. Try to understand and give me the answer. Everyone, please try to understand and give me the answer, guys. The distance between, first you understand what is meant by distance between 2 parallel shafts of 18 mm. So eccentricity, distance between 2 parallel shafts, guys, this one and this one is how much is given? 18 mm. Eccentricity E equal to 18 mm. Take care of the units. 18 mm. And they are connected by an Oldham's coupling. The driving shaft revolves at 160 rpm. So omega equal to how much, guys? Omega equal to 2 pi n by 60. 2 pi n by 60 is the omega, guys. 2 pi n by 60. So I can write 2 pi into 160 by 60 is the omega. Then what will be the maximum speed of sliding of the tongue of the intermediate fish along the groove? Sliding velocity means only one formula, guys, E into omega itself. 18 mm, take care of the units, guys. I want in terms of meter per second. So 18 mm means 18 by 1000 into 2 pi 160 by 60. You get the answer in terms of meter per second. Please verify the answer, guys. How much you are getting? You should get approximately, guys. Yes, 0.3 meter per second, guys. 0.3. Very good. So many students given the correct answer, guys. Really appreciate you. 0.3 meter per second, guys. In case of, listen carefully, sir. In case of this one, guys, double slide crank mechanism and single slide crank mechanism, guys, you have to remember the inversions. You have to remember the inversions. Like no need to remember the first inversion, second inversion, third inversion, fourth inversion, guys. Remember, suppose whenever they given the Oldham's coupling is the inversion of option A, 4-bar mechanism, option B, slide crank mechanism, option C, double slide crank mechanism, option D, triple slide crank mechanism. Don't think it is there. It is not exist, guys. Triple slide crank mechanism doesn't exist, okay? So answer is double slide crank mechanism, guys. Okay, good. Next in point 1 is, guys, this is inversions, guys. After inversions, in point 1 is this mechanical advantage formula, guys. If you take a mechanical advantage, this you study in your engineering mechanics as well. Generally, if you take any lifting machine, like if you are using a cranes or levers to lift the objects easily, or pulleys to lift the object easily, guys, we can formalize load by effort, guys. Mechanical advantage equal to load by effort. That must be equal, I can say, output torque by input torque. In case of 4-bar mechanism, guys, load by effort that equal to output torque by input torque that equal to output force by input force, guys. Okay, output torque by input torque. In case of slide crank mechanism, because output you're going to get a slide crank mechanism, you're going to get a force, not going to get the torque, because output is having a sliding motion, so it is going to get the force only, not the torque, guys. That's why output force by input force. So definitely I can able to say for a 4-bar mechanism, remember carefully, till this remember, that is these things are not required for gate point of view. T4 by T2, output torque by input torque, that equal to omega 2 by omega 4. Why? Because, guys, power is same, na? The power is same, I can able to say power at the input must be equal to power at the output, guys. Power at the input link is second link, so I can write down, guys, here T2 into omega 2 must be equal to how much? Yes, T4 into omega 4, guys. So T4 by T2 equal to omega 2 by omega 4. Now here understand, there is one technical term is called toggle position. Toggle means the extreme position of an output, guys. Extreme position of an output, guys, is called toggle position, or extreme position of a rocker, guys. Now observe carefully. In case of a crank rocker mechanism, in case of a crank rocker, so like input is crank, output is rocker. In the extreme position, when we get the extreme position, guys, whenever crank and coupling rod, getting yours, everyone, guys, both are in line, you get the extreme position. At this extreme position, its angular velocity will be 0. Why? Because it has went here and it won't move further down, because it's a rocker mechanism, means it will go here, it will come back. At the extreme position, what happens? Velocity will be 0, which means that from this position I am going, here I am going, I become stopping for a moment, again turning back, coming here, stopping for a moment. So at this instant, at the extreme position, my instant velocity will become how much, guys? 0. So definitely, guys, I am going to get omega 4 equal to 0. When omega 4 equal to 0, I am going to get the MA equal to how much, guys? Infinity. Similarly, in case of slider crank mechanism also, what is going to get, guys? In the extreme position, my velocity will become 0, guys. Velocity of slider will become 0. You get MA equal to infinity itself, guys. Next, quick return ratio. Very, very, very important. These questions will be coming from 2 marks question. From the quick return ratio, I am going to get a 2 marks question, guys. First, I briefly will explain you what is meant by quick return ratio. Guys, as you know that some of the machines some of the machines, guys. So forward stroke is a cutting stroke, return stroke is a idle stroke, some of the machines, guys. So to do the machining fast or to reduce the cycle time, guys, what you can do, cutting stroke is not in my hand, because if we cut fast now, we get the uneven surface, guys. It has to cut slowly itself, guys. But where I can reduce, guys, to reduce cycle time, I can come quickly. So while I am going working stroke, I go slowly, guys. But in the return stroke, I come quickly. So for this, we need some mechanism that is called quick return mechanism. Then they used to ask, what is the quick return ratio, guys? Quick return ratio means time of cutting time by return time, guys. Cutting time by return time, or that is exactly proportional to the angle turned in the cutting by the angle turned in the return, guys. Angle turned in the cutting by angle turned in the return itself, guys. And this is the one is offset sliding mechanism. Please go through it, guys. Offset sliding mechanism, what happens, we should know the extreme positions first. Once you know the extreme positions, we can able to get the quick return ratio as 180 plus alpha by 180 minus alpha. This is not that much important, guys. Mostly questions will be coming from Whitworth and crank and slotted lever mechanism. Whitworth and crank and slotted lever mechanism, guys. So for this, I will give you a small shortcut, guys. Remember this one. Listen carefully, sir. The formula is, remember carefully, the formula is, guys, theta by beta. Theta by beta means this is a QRR equal to, remember this one, guys, 180 plus 2 alpha by 180 plus, guys, 180 plus 2 alpha by 180 plus 2 alpha by 180 minus 2 alpha. Here, how can you get alpha, guys? Listen carefully, sir. So here, formula is sin alpha equal to, listen carefully, sir. Here, larger dimension by smaller dimension in the between crank and connecting rod, smaller dimension, guys, larger and smaller, guys. Okay, now observe carefully, guys. In case of Whitworth mechanism, what is going to happen, guys? Fixed link is a smaller, getting us, everyone, and this link AB is I can say connecting rod, guys, exactly. So it is a larger link, but in case of crank and slotted lever mechanism, what happened? The fixed link is a larger, guys. Fixed link is a sorry, guys. It is a between crank and 1 second, sorry, mistake. Smaller and larger dimensions between what exactly? Between crank and fixed link. Between crank and fixed link. Please write down this one, guys, if you wish. Between crank and fixed link. I don't care about Whitworth or crank and slotted lever mechanism. If I remember this formula, you can able to solve it, guys. Smaller dimension by larger dimension. Between what exactly? Between crank and fixed link. So by seeing the question, I can even understand what is a fixed link, what is a crank. I can able to understand myself itself. So I can easily able to identify the smaller dimension by larger dimension, guys. You have to remember this formula: 180 plus 2 alpha by 180 minus 2 alpha, guys. Okay, and this is also not required. Mostly questions will be coming from Whitworth and crank and slotted lever mechanism, guys. Okay, now I will give you one question. Please try to solve this exact question given, Please try to solve this question. This question given for 2 marks. This question given for 2 marks, guys. Please read the question carefully. Try to understand. I am giving 2 minutes of time. I'll explain the concepts for you, guys. Please try. Okay, I will give the clue also, guys, here. First, the Whitworth. Where is the Whitworth or crank and slotted lever mechanism? My formula is simple formula. QRR equal to how much? 180 plus 2 alpha by 180 plus 2 alpha by 180 minus 2 alpha. Clear? Now, sin alpha equal to how much formula, guys? Smaller dimension by larger dimension. If you observe carefully, guys, what is smaller dimension here? Observe carefully, sir. So AO, this is the one he has clearly mentioned. This is the crank, he is rotating this one, guys. You can see This is rotating this one. He himself is clearly mentioned. It is rotating this one. This is the crank. So between fix and the crank, what is smallest dimension, guys? AO. What is the AO length, guys? 150. What is OP length, guys? Is a 300. OP length is a 300, guys. The answer equal how much? 1 by 2. 1 by 2 means alpha equal to how much? 30 degrees. If alpha equal to 30 degrees, guys, please identify and give the correct answer now. At least now. Alpha equal 30 degrees now. So how much I am going to get, guys, here? 180 plus 2 alpha 60 by 180 minus 60, guys. So 240 by 60. Sorry, 120, guys. That equal to 2. The answer is how much, guys? 2. That's it. I hope this is clear for you. Okay. Just remember this formula, guys. 180 plus 2 alpha by 180 minus 2 alpha. Here sin alpha equal to how much, guys? The ratio of smaller dimension by larger dimension. You can forget remaining everything, guys. Okay. If you remember this one, high possibility of getting the question from this one, guys. Okay. Yes. Next one, guys. Next one, velocity analysis. In the velocity analysis, guys, high probability of getting one question from the velocity analysis. But here two methods I can able to do it, guys. First one is using your graphical method. Second one is, guys, using a, tell me, guys, using a eye center method. Using a eye center method, guys. Now observe carefully. So here velocity means r into omega, guys. Velocity means r into omega itself. Here basically, sir, you have to remember two special cases. High possibility of getting the questions from two special cases, guys. 19 and 20. Whenever AB parallel to CD, if input and output links are parallel, guys, let me write down, guys, here this special case. The input and output are parallel to each other. Parallel AB, CD. When input and output are parallel each other, angular velocity of this one equal to omega 3 equal to 0, guys. Omega 3 equal to 0. And velocity of B, this is the velocity of B, this is the velocity of C, guys. So what is the velocity of B must be equal to velocity of C, you will get. Once you draw the graphical diagram, you are going to get velocity of B must be equal to velocity of C. What is the velocity of B, guys? They mention, guys, omega 2 and the length of the second link na L2. This one how much, guys? L4 omega 4, guys. How much I am going to get? Tell me, sir. Omega 2 into L2 must be equal to omega 4 into L4. The velocities I am going to get, guys. Getting yours, everyone? Omega 2 into L2 equal to omega 4 into L4 I am going to get. And second case is, guys, when AB, please write down if you wish. Please write down. I am giving 30 seconds of time. Please write down, guys. So VB equal to VC and the angular velocity of the coupler will be coming 0 itself, guys. So then omega 2 L2 equal to omega 4 L4, guys. Next. If AB parallel to BC, AB parallel to BC, what is this position is called? Can you please guess? Just 5 minutes back only we discussed them. What is this position, guys? What is this position? Yes, it is the toggle position. In the toggle position, without second that I told you, sir, in the toggle position, what happened? Output link is going and stopping for some moment, guys. So what is the angular velocity of the output link, guys? It becomes 0. Angular velocity will become 0, guys. Then what I am going to get, guys? So omega 2 L2 must be equal to omega 3 L3 I am going to get. Omega 2 L2 must be equal to omega 3 L3, guys. Getting an answer, everyone? Next, one more thing I would like to say here. Listen carefully, sir. This is very, very important, Amma. Please, it is not there in your summary. Suppose if I am having any one link is given, listen carefully. This link is given, listen carefully, sir. This link is given. Suppose if I know, listen carefully, sir. Assume this is the velocity, this is the A, this is the B, guys. I can say that this is the velocity at A is acting in this direction at an angle of alpha, at an angle of alpha. Next, velocity at B, assume it is making an angle like this, guys. Velocity at B, which is making an angle of beta, guys. It's making an angle of beta itself. If you take this angle, if I know absolute velocity at this location, guys, now I am represented, guys. Then they used to ask, what is the relation between these two? Very frequently they used to ask the question. The simple way of solving this one is, guys, assume the link is a rigid link now. As the link is a rigid link, what happens if this end is moving with 2 meters per second? How much is the velocity of this end also, guys? Same 2 meters per second. Am I correct or not, sir? If this end 2 meters per second, this end also 2 meters per second, guys. This end 5 meters per second, this end also 5 meters per second in the same direction, guys. So what I can able to say? So resolve this one in this direction. If I resolve, what I am going to get, guys? If I resolve this one, so what I am going to get, observe carefully, sir, VA cos alpha. This side should be how much, guys? VA cos alpha. Next, this one how much is coming, Amma? VB, resolve in this direction, guys. VB cos beta. As it is a VB cos beta, definitely what I am going to get, guys, these two must be same, Amma. So whatever the velocity of the link at this point, this other point also should be having the same itself. Why? Because the link is a rigid link. So definitely I can able to say VA cos alpha must be equal to how much, guys? VB cos beta. Are you getting or not, sir, everyone? Clear? This one also, why this VB equal to VC, I will tell you, guys. See, I am taking the same link itself, coupler link itself. Listen carefully, sir. I know that the resultant velocity of the B will be this direction. This is the direction VB. And I know that resultant velocity will be how much, guys? VC will be in this direction, guys. And this angle is how much? Alpha. Yes or no? This angle also how much? Alpha itself. Then resolve, Amma. If I resolve, what I am going to get, guys? VB cos alpha along the link side must be equal to VC cos alpha itself. Cos alpha getting striked off. Ultimately, I am going to get VB equal to VC only. I hope this is clear for you guys. Understood or not, sir, everyone? Yes.